It occurred to me when I was presenting this, or preparing this, that my first code bean, but it was called Erlang User Conference back then, was 1997. That was 25 years ago. And I actually presented something that you could say was a predecessor of what I'm going to be presenting now. So this is a little bit of an anniversary of those ideas. So I'll quickly describe the problem we were trying to solve, and then I'll do some war stories. That's the privilege of graybeards. And then describe the solution we landed in. So I work at the Aeternity blockchain core team, and that's an Erlang-based, fully featured blockchain node. So we started developing that essentially from scratch in 2017, and we went live in 2019, and then we had a little bit of a sort of a dip in terms of core team size when we went into maintenance during 2020 and 21. And then we started beefing up the core team again, and we actually involved some other graybeards like Sean Hind, Chandru Molaparty, and Craig Everett. So we have quite an exciting team again, and have picked up speed and are implementing new features. So among the features that we wanted to implement were, for example, we needed to start supporting runtime modes. Like one of the things we wanted to do was to be able to support chain rollback during certain attack scenarios or whatever. Also during testing, you may want to roll back the chain to a certain point and then perhaps rejoin the network if you're kind of stuck on the wrong fork or something. And but of course, when you roll back the chain, essentially delete a bunch of stuff from the database, it would be nice to turn off sync and transaction processing during that time. Otherwise, the system is likely to crash. So we wanted to implement some maintenance mode. And while we were at it, we also wanted to implement some development mode where we could just enable on-demand block production much quicker, and possibly go from having a live chain to just enable dev mode, which would turn off all the networking and allow you to do prototyping based on the existing chain. So that was one thing. And that would, of course, mean that in runtime, we need to start and stop applications based on the scenario we wanted to implement. We also wanted to support plugins. So for example, dev mode, we wanted to have a separate application that we would just essentially load on demand into the system, which would then configure itself. So now, I was at the AXD 301 project, and I guess a lot of you perhaps don't know what that is. That was an ATM switch that Ericsson started developing in 96, 97. ATM as in asynchronous transfer mode, which is a datacom protocol that perhaps, well, it is actually still in use. It just isn't so much used by end users. Now, we started out with essentially a house and 200 people, like 50 to 70 Erlang developers. But this was, we started before there was a version 1 of OTP. So we actually started doing work on the predecessor of OTP, BOSS. So we didn't know exactly what the middleware was going to look like or the platform was going to look like. We had some idea. But it turned out that we were a little bit surprised when R1A came out, because we had planned on OTP including a cluster controller. Miscommunication between the teams. And as it goes in big projects, all our developers were already allocated. I was on system management, so I was basically the only free developer we had, so I had to implement a cluster controller. we were also missing some automatic installation support. So we had a bunch of teams, and they were sort of building boot scripts and everything according to the OTP manual, but going about it slightly differently. And that caused a bunch of collisions during integration test, and it took a long time, so we needed to automate that. And that was actually during one summer vacation. We were like 2 guys working in the office, and so we built some installation software. And so the cluster controller in the AXD 301, we were using mated pairs, like control processors in pairs, 1 active, 1 standby. We could have 16 pairs, like up to 32 processors. We also had an idea to distribute much further so that what's called the ATBs there, ATM termination boards, that we thought that, hey, if we could run Erlang on them, we could have up to 256 nodes. And so the cluster controller was designed to handle these cases. And we also had the idea of administratively blocking a node. If you wanted to do maintenance and debugging on a certain node, you could take it out of service. So the cluster controller needed to support this. Essentially, when you go into administrative block node, you turn off the call control applications, things like that. We also had logic so that if, say, the active node went down, the standby would take over. Then when the other node came back up, it would become the new standby, so that we wouldn't do takeover unnecessarily and risk losing calls. So the RCM was what I presented at the Erlang user conference in 1997. It was the Runtime Configuration Manager, our cluster controller. This was actually developed in parallel with the OTP distributed application controller, the dist-AC. I don't know if any of you have used that. And we went through a couple of iterations trying to figure this out. And Martin Björklund was at the OTP team, and he was doing the application controller stuff, and I was doing the RCM in the ATM project. One of the iterations we tried was using permissions. So if you've seen in the application controller, there is a permit app where you can basically say this application is allowed to run or isn't allowed to run. We figured out pretty recently that since it's probably not used by anyone, it turned out that it doesn't work together with application ensure all started, which, for example, Rebar is using in the Rebar console command, which probably everybody uses. So, and it turned out that it was pretty hard to fix. So that was something I scrapped when I was looking into how to support maintenance mode in the Eternity node. But the thing we landed in with the application controller and RCM, the code snippet there is from the application controller.erl file. It documents a protocol between dist-AC and the application controller, where you have application load requests, application start requests, run, not run commands, and then stopped, unloaded, things like that. And so the way we solved it was RCM would start up and basically take control of the applications and then use this protocol to talk to the application controller. RCM also had some abstractions that we found useful. Logical processors, for example. We wanted to use the configuration, not the node names, because the node names would be different on the target environment and in a development environment. So we just had atoms like CP1, CP2, up to CP16, or CP32. And then we had a pool concept, either mated pairs or pools. And on these, we would allocate roles, and the roles would expand to applications. And then we also had the administrative status of the processors. Unfortunately, This was sort of proprietary development, so this never became open source. We also built an installation tool called sysInstall for AXD 301. It would basically go out and find all the versions and everything and generate the rel files and boot scripts. The stuff that RelX does for rebar programmers nowadays. Here we actually did make a simplified version called Builder that you can find in Jungle. And Jungle you can find in some GitHub mirrors. It was actually an SVN repository, SVN for Subversion, which probably predates or is older than many of you. That's what everyone was using before Git. And that was just a big code tree with a bunch of applications that people could use, Erlang programmers. And one thing about Jungle, it was Mats Kronqvist and I developed that. I was kind of experimenting with the idea that you could be working on an application and then you would write an installation script or parameters for your application, and then if you wanted to build the next application that depended on the other application, it would just include the installation instructions from the other application, and then you could just iteratively build a bigger project. CIAN, which was the comprehensive Erlang archive network made by Michael Raymond in 2006, and Process One, was actually using Builder. In 2010, Tino Bredin and I wrote sort of a slightly modernized version of this, and we were using it in the Vocalink faster payment system prototype that we were working on at the time. It also had the installation support boot script generation. Maybe nowadays that's not so interesting to talk about because it's a solved problem through, as I said, RelX, for example. But it also had some other things that we copied from AXD 301. For example, it has an API where you can find out where home is for your particular application, data directory where you can put your database, whatever, log directory where the logging is. So it just gives you a unified API for knowing where to put stuff. It also implements start phases. I will give you some examples of that. And this is something that becomes very important in very complex systems because, and it's actually sort of mimics the way it was done in the Ericsson AXD switches. They had numbers start phases, and then they had documentation saying, well, in start phase 17, this happens. So then you could actually hook into start phase 17 and then get stuff done. And so then you had a very structured initialization procedure for the system. Now, OTP, by default, does things pretty organically. Things just happen, possibly in parallel and everything. And that can cause surprising things to happen occasionally. So personally, I think that this is a pretty good way to initialize a system. Another thing that I have found valuable is, and if any of you have been using Xmeter, for example, you've seen that you can actually configure your metrics in your local application environment, and Xmeter will find them. So that's that and some other things are also in this setup application. And it also has some support for automatic upgrade. Like you can actually install a new version of an app, and setup will automatically generate an upgrade script to load the new application and transfer all the states, run all the upgrade hooks, and so that you could smoothly upgrade, patch an individual application. So we're using setup in Aeternity, and we have actually for quite a while. And so up here you can see some examples of the start phases where start phase 100 is the first one, where we just, so essentially the AEUtils application will tell via the setup hooks environment variable, that setup will go out, it will check all the applications for this environment variable. And then if it finds setup hooks for like normal startup mode, you could have, say, an upgrade startup mode or installation startup mode as well. We're not using that. So basically, start phase 100, it will read the config. And then 101, it will apply OS environment variables. So you can redefine config variables using OS application environments. So those are hooks that are called by setup. And then we added the load plugins start phase. So it looks into the configuration files to see if there is a plugin that should be loaded. And then you just have a plugin directory root where it's supposed to be. So fairly simple. An example of a start, other places where we use setup, for example, when we initialize the database, it says add backend plugins. It's a little bit, or maybe it's my eyes. I took my glasses off. It says run hooks, like the add plugins. So you could possibly have an application that adds an index plugin or a database plugin into Mnesia. It would then, so it calls on setup to find the environment variables, for example, AECDB add plugins. So if your application has registered such a hook, it will be called then. So app control then. This is the successor of RCM. But since we don't have a distributed system, we're not using distributed Erlang at all. I haven't implemented any of the cluster control stuff yet. Just node local control. So the way it works, you define your roles. Like, for example, we have basic, active, and the dev mode. And you can specify that the default mode is normal, and then you define your modes, where normal, then you run basic and active. Maintenance, you run just basic. And dev mode, you would run basic and dev, for example. And these can be modified in runtime as well. And then there is a thing called protected mode apps. So an application can tell app control to modify the protected mode apps list and add applications there. I will mention what that does later. So we have two mappings essentially for now, role to applications and mode to roles. And so the way it works is that the application control server will just figure out all the application start dependencies and all the configurations for that. And then it will start one process per application that it finds. And that process will tell the application controller that I am now in control of this application. So it's a simple state machine where it implements this protocol with the application controller. So the application controller will say, okay, can I start gproc? And it says, yes, go ahead. After talking to the application control server, saying, okay, is it okay to start this application? It looks up in the mode configuration or whatever and says, yeah, sure. And then the application is started. So fairly simple. One thing that I can note is I also added gproc pub/sub event reporting. And one reason, I don't know if this is actually a real-life problem, but with the introduction of Logger, since you can actually configure Logger to not send SASL reports, if you have an application that depends on the application started info reports, they may not actually get delivered with Logger, depending on what the configuration is. So that I thought that, well, hey, let's put in a pub/sub API, and we don't have to worry about that. Okay, there is a big hack. because the application controller, if it's dist AC, it will actually be called by kernel, which is what you want, because you don't want the application controller to start a bunch of applications while the app control is trying to figure out which apps to control. So how do you hook into the kernel and say, run this code? I didn't really find a good way to do that. So what I did, you can plug in a logger module. So you configure this add bootstrap module. It's a dummy logger. It doesn't listen to any events. The only thing it does is when it initializes a state, it starts the app control server. Now this is a problem because the app control application hasn't started yet. So when it starts, it starts an application control supervisor, which starts an application control server proxy, which finds the application control server, links to it. So if it dies, the proxy dies, gets restarted, and then it restarts the application control server and updates the dummy logger. Really ugly, but it actually works. So essentially, this is what happens then. Standard lib and kernel, you don't control those because you're not allowed to stop them. They have to run. But the kernel will bootstrap the application controller, app control server, which first starts the protected mode apps, which are essentially app control, setup, and gproc. And any applications that you also want to run in the protected mode, like logger, logging, for example, or Mnesia, perhaps. Once all those are started, it checks what the next mode should be. And if it's normal, for example, it will start all the applications that are allowed to run in normal. And then you can use the set mode or set and await mode if you want to change to something else, like maintenance mode. You just call that function. It will reconfigure the system and return when all the changes are done and all the system is stable again. So what you would do then for a plugin, you can register with the app control, say the dev mode plugin actually adds itself to the basic role, should add itself to the dev mode or dev role, but that will work too. And then it can also add itself to setup hooks, register setup hooks like check environment, which is one thing that we do. Like we have this config environment in a JSON schema-driven way, and then you can check those and act on the environment. So essentially, then a plugin is an OTP application, and it gets started or stopped based on the app control rules. And it can register itself with setup and for hooks, and also figure out where to put data and stuff like that. So that's essentially it. Now, for distributed application control, very quickly, there is a PowerPoint in the app control repository where I outline some of the principles borrowed from the RCM project. And John Hughes actually wrote a quick check, or an attempt at quick check modeling. We thought that we would actually try this, and then we got distracted to essentially do a sketch, do a quick check model, and then write the code. Or at least I've saved the quick check model, but I haven't actually started writing the code yet. So, but if you want to contribute, this could be a good place to start, to read that, and try to implement cluster control that way. So, we don't need distributed application control. I don't know how many do nowadays. We've heard some talks about cluster controlling here. The plugin upgrade support, I think I need to work on to make it function a little bit easier so that you can actually easily upgrade the plugins. Now, Sean Hind has some ideas from his Synap days and telecom days on making better configuration management support. Now, that's an eternal problem, so I don't know if he's going to succeed, but if he does, that will be released to him. And we're just started using his CLI library, which is actually excellent. So we will keep working on this, and the code is out there. I updated the documentation, so feel free to use and contribute. So do you have any questions?
We're out of time, I'm sorry.
Yeah.
But please
25 minutes goes by quickly.
Please write your questions in the WoW app, and I'm sure you will be able to answer them in writing. Yes.
Yep.
Thank you.